Hi there, in this section we'll be looking at evaluating definite integrals using the substitution method and close up this particular section with finding the area between curves. We'll start here with evaluating our definite integrals because this really should pick up where we left off from our last section, but this is just finding, obviously we'll be evaluating now. We won't have the plus c because it'll be a definite integral, but we've actually already done a section on definite integrals. We just didn't have the u substitution under our belts at the time. So this will essentially be looking at doing the u substitution and evaluating definite integrals in that format. All right, so with that said, looking at this problem here, I want to evaluate from 0 to pi of sine x cosine cubed x. Now remember, as we've talked about before, that this is equivalent to, we can rewrite in this format, the integral from 0 to pi of sine x times cosine x all cubed dx. So these notations, this cosine cubed x is the same as cosine of x all cubed. All right, so now let's let our u be the function within a function. So let's let u equal cosine x, because now if I take the derivative of that cosine x, derivative of cosine x, a negative sine x dx. If it's always taking the derivative of the argument itself, but the derivative of x here is just 1. So I get du then as negative sine x dx. So that takes care of my sine x dx, but I have an extra negative 1 here, so I'm just going to divide both sides by negative 1 and say, okay, well, negative du then equals sine x dx. Okay. So now when I go to plug in, I have taken care of, these two pieces here have taken care of the du. So this is then u cubed, so I have u cubed du, and then again I had that extra negative, so I'm just going to factor it out front. Now you have a couple options whenever you're evaluating definite integrals using a u substitution. I'm going to demonstrate both for you here on this first problem, and then let you decide from there how you would like to proceed. So one method is that we can keep, instead of, if you recall in our last section, whenever we integrated with respect to u, at the very end we went back and substituted in what our u was and got everything in terms of x. So we can still do that method, and if we do it that way, we'll still be evaluating from 0 to pi. Another method is to keep everything in terms of u, and then let's put down new limits, new upper and lower limits for in terms of u. Okay, so like for example, if I want to figure out if I'm integrating with respect to u, then I come over here to my u function and I plug in my upper and lower limits. So I would find the cosine of pi and the cosine of 0. So I'm plugging these two values, these upper and lower limits, into the u function itself to give me new upper and lower bounds. So the cosine at pi hopefully agrees -1, cosine at 0, +1. So I would be running this one then from 1 to -1. Okay, so again, this is one option. So now I'm going to now take my integral like I normally would. So this would become then u to the 4th. I'm adding 1 to my exponent, reciprocal, bringing down that negative that's on the outside. And now I'm going to evaluate it from 1 to -1. I do not have to substitute back in for the u at this point. So now I'm going to come down here. I'm going to first plug in -1. So I have -1/4. Plugging in for u is -1 to the 4th power. So I plugged in my upper bound, minus, plug in your lower bound. So -1/4, lower bound's 1, raised to the 4th power. All right, so then we just start to clean up. Of course, you can use your calculator. I'll just talk you through it, though. A negative raised to an even power comes out positive, and so 1 raised to any power is still 1, times the -1/4. If you agree, that's going to put you at -1/4, minus, on the back bracket here, 1 to the 4th power is still 1, times -1/4. It's going to get me a -1/4. Two negatives side by side turn into a positive. And so 1/4 minus 1/4 gives me a total area then of 0. All right, so I had said, okay, that's one way. The other way is to recall what we did on our previous section. Once we got our integral, then we went in and we substituted what we knew. Let's get us a different color over here. So we said, okay, well, this is -1/4. U is cosine x, and then that's being raised to the 4th power. And then you would evaluate it with your given limits of integration, so 0 to pi. You're going to see, though, you're going to land in the exact same spot. So you have negative 1/4 cosine of your upper bound, pi, raised to the 4th power. So I plugged in my upper bound, minus, plug in my lower bound, negative 1/4 cosine of 0 raised to the 4th power. All right, so like hopefully you can kind of already see, hey, I'm landing in the same spot here, right? Because cosine of pi, negative 1. And over here, negative 1/4 cosine of 0, positive 1. So we're ending up in the exact same work that I have then, negative 1/4 minus a negative 1/4, which would put me at 0. So either way you want to do it, it's a little cleaner over here on the left, the way that I did it from the beginning. So that's the way I'm going to continue to show it. But if you would prefer to do it over here on the right, you'll still get the exact same answer. All right, I'm going to come on down then. In the next example, we are evaluating this from the square root of 5 to the square root of 10 of 3x on the square root of x squared minus 1. So there's no way for me to distribute and just be able to use my power rule, so I am going to need a u substitution here. So pick in my u, typically, like we've said before, use the function within a function. And you know what might be even better before I do that is let's think about a way we could rewrite this. That square root is the same as x squared minus 1 raised to the 1/2 power. All right, so then if I let my u equal x squared minus 1, that's the function within a function, the base on the base raised to a power. Derivative of that then is 2x dx. Okay, so now you can see then your du is taking care of the x dx, and I've got this extra 2 here, so we talked about in class, well, just divide by 2, so I can say then that 1/2 du equals x dx. So now the x dx is being taken care of by my du. I have this extra 3, but the 3 can be factored out as well as this 1/2, so that's going to become 3/2 on the integral of u to the 1/2 du. Right, because this piece right here, that's my u. All right, so now if it's all in terms of u, let's get my new integration limits, because it was the square root of 5 to the square root of 10. So let's get our new integration unit. So I come over here and I'm going to plug in square root of 10. Plug it in for my u, so I'll have the square root of 10 squared minus 1. So anytime you take a square root and you square it, you just get that number. So you get 10 minus 1 will get you 9. So I've got 9 up top. On the bottom, I'm plugging in the square root of 5 squared minus 1. So it's taking a square root and squaring it. You just get what's inside. So 5 minus 1 get me 4. Okay, so now from here, I'm ready to take my integral. So that 1/2, I'm going to add 1 to that exponent. So that's going to become u to the 3/2. Reciprocal now 3/2, 2/3, times this coefficient that was on the outside here, 3/2. All right, and then we know that we're going to be evaluating it from 4 to 9, but even before I do that, let's clean up. The 2/3 and the 3/2 cancel out, so I can make it even cleaner. Say u to the 3/2 from 4 to 9. Okay, so upper bound 9 to the 3/2 minus lower bound 4 to the 3/2. That should give you 27 minus 8, which is 19. Final answer. Okay. Right, I'm going to come on down to this last example. In this last example, so again, I'm not going to be able to distribute that x through here because this second term is being raised to the 4th power. So I'm going to need to use a u substitution. All right, so I'm going to let u equal the function within a function. So let u equal x plus 1. Du then is going to be a 1 dx. All right, so I've got this part taken care of and I got my dx, but I've got this extra x sitting out here. So if you recall, one of the techniques that we talked about in the last section was that, hey, I can take my u Because if I'm gonna write this in terms of u and dx in terms of du, then I need everything in terms of u's and du's. So let's rewrite then. Sorry, take we want to solve for x in terms of u. So take your u that you've already established, that u is equal to x plus 1, solve it for x. So that's just a one-stepper, right? Subtract 1. So x equals u minus 1. So now we can say then, okay, well, x is equal to, I'm going to kind of do like I did in class. So x is equal to u minus 1. X plus 1, we define that to be our u to the fourth power. And our dx is equivalent to du. Okay. Let's get our new limits of integration. So my color. All right, so if I put in my upper bound as 1, so then I would have 1 plus 1. Obviously, that's going to give me 2, so new upper bound's 2. Lower bound's negative 2, so I have negative 2 plus 1, so that'll land me at negative 1. So I'll be looking at this from negative 1 to 2. I'm not ready to quite take my integral yet, though, because I need to be able to use my power rule. So let's take that u to the fourth and distribute it through. So I will have the integral then from negative 1 to 2, u to the fourth times u to the fifth, u to the fourth times 1, so minus u to the fourth du. Now we're of the form that we can use our power rule. So add 1 to my exponent, reciprocal, minus add 1 to that exponent, reciprocal. All right, then we're going to evaluate from negative 1 to 2. We'll put in that upper bound first, so everywhere I see a u, I'm going to plug in 2, so I'll have 1/6 to the 6th minus 1/5 to the 5th. So that's plugging in my upper bound, minus, now I'll go through and plug in my lower bound. 1/6 times negative 1 to the 6th minus 1/5 times negative 1 to the 5th. All right, so then let's start cleaning up. All right, so of course you can use your calculator. I'm going to talk you through it though. So 2 to the 6th, that should land you at 64. So then that puts me at 64 over 6. Of course, I know that can be reduced, but I'm just going to keep it there for now. 2 to the 5th is 32, so I've got 32 over 5. All right, then back here, a negative, so 1 raised to any power is still 1, then a negative raised to an even power is going to be a positive, so that'll land me then at 1/6. Let's see, might need to change my sign back here. Let's see what's happening. I got a negative raised to an odd power, so that'll be negative times a negative, so yep, I'll have a positive 1/5. All right, so then I'm going to let my calculator help me out. 64/6 minus 32 over 5 should land you at 64 over 15. Bringing down this minus sign. 1/6 plus 1/5 should get you 11 over 30. Subtract here. Final answer then, 39 over 10. Okay. So I definitely encourage you, pause the video at any time that you need to so that you can get caught up and process and make notes of anything you need to ask about. Okay. All right, I'm going to flip it on over. And in these last few examples here, we're going to talk about finding the area between two curves. So if you recall, anytime we find our integral always finds the area underneath that curve bounded by the x-axis and your curve itself. So if we want to find the area between two curves, hopefully the idea here will be pretty straightforward for us. Pen going. It's always going to be the area under the taller curve, or the area on top, and then you're going to subtract it from the area of the shorter curve, the area on the bottom. So if you look at here, I've got two parabolas here, right? Here's my f of x function. That's the function here in this red. So there's my f of x function, and I've defined it for you here, right? Parabola facing downward. My g of x function, parabola facing upward, having a minimum point here at that positive 4, but there's my g of x function. And so then you can see, well, then the shading is overlapping here, and I want to find the area between those two curves. So this shaded region is the area that I'm trying to find. And so you can see then, I want to identify where these two spots are intersecting there, okay? And hopefully you can eyeball that. That's coming down here at the -1 to +1. So I'm going to be interested in the integral from -1 to +1. Then I've got to be sure that I write this right, okay? So the area of the graph that's on top, so that's my f of x function, minus the area of the graph that's on the bottom, my g of x function. That's going to give me the area between these two curves, okay? It's always the top minus the bottom. All right, so then again, I'm just going to remind you, hey, I've given you up here, I've given you the formulas for those two functions, so I'm just going to come down here below and I'm going to substitute these in for my f and my g. All right, so I've got the integral then from -1 to 1. Your f of x function, that's your 7 minus 2x squared, minus your g of x function, your x squared plus 4 dx. All right, so now from here, I'm going to take that minus sign and distribute it. So keep burning a step here. So I've got 7 minus 2x squared minus x squared minus 4 dx. Combine like terms. -3x squared plus 3 dx. Still from -1 to 1. From here, you're ready to take your integral, okay? And if you'd like, I definitely encourage you, pause the video, try the rest of it on your own, and then you can come back and check yourself, okay? All right, so now I'm going to add 1 to that exponent, so that'll give me x cubed. Got my 1/3, doing reciprocal of that 3, bringing down the -3 that was already there. Integral of 3, just 3x. Now, I didn't do a u substitution here, so I didn't have to worry about changing my limits of integration. They're still -1 to 1. So I will clean up, though, and say, okay, well, I have -x cubed plus 3x, and I'm evaluating from -1 to 1. Again, I only change those limits of integration when I use a u substitution. Otherwise, you're plugging in the ones that you're given. So this tells me then I'm putting in my upper bound first. Minus, plug in your lower bound. So that will give me then -1 plus 3. -1 cubes negative times negative, so +1. Just take out that +1 minus 3. So that gives me then 2 in that first bracket. Take down the minus sign, a -2, and 2 negatives side by side turn into a positive. So that gives me an area then. We are talking about area, so 4 is fine. If you recall, since area is always square units, you could say 4 units squared. Okay, but again, I'm okay with writing the 4 only. Okay. All right, I'm going to flip it on over to the next page. Try the next example. In the next example, I haven't given you a picture, but you can utilize your calculator to get your pictures for you. But also, notice that I've picked 2 relatively well-known functions as well here, okay? So I am going to go ahead and crank out the graph for us. So we are looking at take this -x squared plus 1. So that means I'm going to be crossing the x-axis. That's going to be a parabola, x squared, right? X squared tells me I'm a parabola. It's been shifted up 1 unit, and because it's negative, it is facing downward. So it looks something like that. And then g of x is equal to 2x plus 4. So that's a linear line. So here's 1, 2, 3, 4. And then you go up 2 over 1, so it's a linear line. So looking something like this. Okay. I want the area between these 2 curves bounded from -1 to +2. So let me get that region shaded here for you. So these 2 values here would be your -1 and +1. So here's -1, And then positive 2 would be out here, roughly-ish. Okay, it's not quite to scale, but essentially then this is the area that I'm trying to find, the area between these two curves. Okay, so remember then is the area of the curve on top. So in our case here, the curve on top, and I'll label it, this was my g function up here, this was my f of x function down below. So this time, g of x minus f of x. They tell us where they want us to evaluate it, from -1 to 2. All right, we'll substitute those in then. I'm looking at the integral then from -1 to 2, g of x, that's my 2x plus 4, minus the negative x squared plus 1. So again, this might be a good one just to pause the video and go the rest of the way and check yourself at the end, okay? I'm going to continue to go on though. All right, so the integral from -1 to 2. I'll distribute that negative through, so I have 2x plus 4 plus x squared minus 1. One more step in. Clean it up before I take my integral. All right. I'm now ready to take my integral. I'm adding 1 to that exponent, reciprocal, so 1/3 x cubed in the first term. Bring down any coefficients that are there. Add 1 to that exponent, x squared, reciprocal of that 2, 1/2, plus 3x. All right, so to clean up here, I've got 1/3 x cubed plus x squared plus 3x. And now from here, I've got it cleaned up, so I'm going to go from -1 to +2. So I will plug in my upper bound first. Everywhere I see an x, I'm going to plug in 2 first. So I have 1/3 times 2 cubed plus 2 squared plus 3 times 2. Upper bound minus your lower bound. Everywhere I'll go back to my function now. Everywhere I see an x, I'll plug in -1. All right, so let's start clean up here. All right, so that should give me, what, 2 cubes, so 8/3 plus 4 plus 6 in the first bracket. Over to the second bracket, get a -1/3 plus 1 minus 3. All right, from here, I would go to my calculator for the first bracket, clean that up, and you should land at 38/3. Same thing for the second bracket, go to your calculator, that should land you at a -7/3. And then 2 negatives side by side turn into a positive, getting you a final answer then of 45/3. Actually, that's not the final answer. We'll make that 15, right? So 15 will be my final answer. Okay. All right, I'll move on down then to your next example. Finding the area between these two curves. Area bounded by f of x equals x squared minus 18. So another parabola, but this time it's been shifted down 18 units. And then you have a g of x equals x minus 6, so another linear line. Try to get you a rough sketch here in our notes. It will not be to scale, but you can pop this in your calculator to be able to see it better. And actually, you will want to put this one in your calculator. Unfortunately, I don't have a calculator to be able to demonstrate this portion with you. So if you need some help with this, definitely let me know, and we can go over this. All right, so the first one, like I said, is a parabola facing upward, but it's been shifted down 18 units. So I'm just going to call this my -18, and I am going to graph that parabola. All right, and we're going to label that. That's my f of x function. All right, my g of x function has a y-intercept down here at -6. So again, my graph is not going to be to scale. Here's my -6. And from there, I go up 1 over 1. So we know that it's going to be a linear line, and I need to keep it so that it is falling underneath here. There we go. So that looks a little bit closer to what it looks like on in your calculators. We are finding the area then bounded by these two regions. So let me get my shading going on here. We want this area here. Top curve minus the bottom curve. So again, in this curve, I've got my g of x function minus my f of x, all right, because that's the g of x is on top there. Now, the only thing that hasn't happened here is that I haven't given you what your limits of integration are. And in order to find those limits of integration, we've got to figure out where these two functions intersect. So of course we could do it by hand. We could set our two functions equal to one another and solve. But you have a calculator at your disposal, and so in order to do that, you go into your calculator, you put both of these functions into y equals, so put one in y1 and the other in y2, and then you're going to hit, so I can kind of do it and then talk you through it. So it's x squared minus 18 in y1, and y2 I'll have x minus 6. I'll hit zoom 6, then to get my graph. And now to find, if you want to be able to see the full graph, you can change your window, change your y min down, maybe go -20. Then that way you'll for sure be able to see the full graph. All right, so now from here, I am going to go through how do I find these two intersection points. Again, I'm only going to be able to verbally talk you through that. I hit second trace. Number 5 for intersect. Calculator will automatically start you out on one of your curves. For me, it's putting it on the parabola. I just hit enter, and then it said the second curve, so I hit enter. And then I'm going to move my cursor, when it says guess, I'm going to move my cursor to one of those points of intersection, and then hit enter on that guess. You should get this ordered pair right here to be -3, -9. Then we've got to repeat that process and find out what this intersection point is. So I hit second trace, number 5. So again, it's going to automatically put you on one of your curves. For me, it's putting me on that x squared minus 18. I'm going to hit enter on that. Then it jumps you to your second curve. You can hit enter there. But then move your cursor to this point on your graph in your calculator. And then hit enter. And that should give you the point 4, -2. So then you can tell then, okay, I want to go from my x value to x value, so I'm looking at the integral then from -3 to 4. Okay, so again, if you need some help with that, let me know and we can go over that. All right, so I'm going to plug in now integral from -3 to 4, plug in my g function, so I have x minus 6 minus the x squared minus 18. All right. So let's see, I distribute my negative through, so I get x minus 6 minus x squared plus 18. All right, I'm going to do one more. Oops, let me fix that. All right, let's do one more clean up here. So I have negative x squared plus x plus 12. All right, now we are ready to take our integral. So let's see, I've got my x cubed, 1/3, bringing down the negative, x squared, reciprocal, so 1/2 in front, and a 12x at the back. I don't need to clean up any, so I can evaluate now from -3 to 4. Pop in the upper bound, so -1/3 for cubed. So there's the upper bound, minus, plug in your lower bound. So cleaning up. So let's see, 4 cubed is 64 times a negative, so negative 64 thirds in that first term. 4 squared, 16 divided by 2, 8 plus 48. So just I'm cleaning them up, without having really used my calculator at the moment. All right, then come over here. Let's see, negative 3 cubed. That's going to give me a negative 27 divided by a negative 3. So 27 divided by 3 would give me a positive 9. Plus 3 squared is 9, so 9 halves, that middle term, minus 36. All right, so then I'm going to my calculator. I'm putting the first bracket in. That should land you at 104 over 3 minus, now I'm going to go back here to the second bracket, put that in all of my calculator, and that should land you at a negative 45 over 2. Final answer then, 343 over 6. Approximately 57.17 if you wanted to get a decimal approximation. Typically we like to keep them exact. Okay. All right, I'll flip it over to the last page. In this particular example, it wants us to find the total area of this function from negative 2 to positive 2. So I'll let you take a moment, put that in your calculator. Interested in from negative 2 to positive 2. I'll do my best up here to get us a picture. But if you took the time to put that in your calculator, it should look perfectly symmetric, okay? We are trying to find the total area, so we want this area and that area. So there's two ways to think about this, okay? So I'm going to set you up with the first way first, and then we'll see if you can make that connection of how we could go about this as well. So remember, we want total area, so we know that the area from negative 2 to 0 is going to be positive or negative. Hopefully you agree that would be negative because it's below the x-axis. And then we're going to need the area from 0 to 2 of the same function to get this top portion here, because the area there is positive. So we would need the integral from negative 2 to 0 of that same function, x times 4 minus x squared. We'll go ahead and make it to the 1/2 power dx, plus the integral from 0 to 2 of same function, x squared, well, let's rewrite it, x times 4 minus x squared to the 1/2 power dx. So, we would still go about using a u substitution here, and for both of these and evaluating them. But if this is symmetric, right, and it is, I mean, we can see that. But since this is symmetric, this would be equivalent to, would you agree, 2 times the integral from 0 to 2, right? Because we know that area is going to be positive, so why don't we just focus on the positive side? Let's find the area from 0 to 2 and then double it. Okay. I challenge you to do, the other part up here on your own, so that you can prove to yourself that you would get the same answer. But anyway, I just thought I would show this to you as well. From here, we need a u substitution. So if we come over, we let u equal, oh, I forgot my 1/2 over here, the function within a function, so my 4 minus x squared. Take the derivative then, I get negative 2x dx. So I needed an x dx. I created a negative 2, so just divide both sides by negative 2. So I can say then negative 1/2 du is equivalent to x dx. So I'm bringing down this 2 that's on the outside. I've got a negative 1/2 that's going to get factored out, so I'll bring that out here. So negative 1/2 integral, and then we know that these two pieces are being accounted for with my du, and then this piece is u to the 1/2. And now, since I'm evaluating in terms of u, I can leave it in terms of u, but just update my limits of integration. So if I plug in 2 for my u, so if I plug in 2, I'd have 4 minus 2 squared, so that would give me 0. So that upper bound is going to change into 0. On the bottom, plug in your lower bound, which is 0, so 4 minus 0 squared, that's going to give me 4. Okay. All right, so now from here, I'm going to clean up on the outside. So half of 2, that's just going to give me a -1 out there. All right, inside here, taking the integral, so I'm adding 1, so that becomes u to the 3/2, reciprocal then 2/3. So let's clean up and say, okay, well then I have -2/3 u to the 3/2, and I'm going to evaluate that from 4 to 0. All right, so plug in my upper bound, so -2/3, 0 to the 3/2, there's your upper bound, minus, plug in your lower bound, 4 to the 3/2. Okay, so we know 0 raised to anything is still 0, times anything still 0, so that first one's turned into 0, bringing down my minus sign. Now back here I have then -2/3 times 4 raised to the 3/2. Let's see, that's going to be the square root of 4 is 2, 2 cubed will be 8. So that will turn into what, a -16/3? 0 minus a -16/3, which 2 negatives side by side turn into a positive. 16/3 is my final answer. If you go back up here and go back to this problem here, you're going to find that the area of this side is 8/3 and the area of that side is 8/3, and 8/3 plus 8/3 is going to land you at 16/3. Okay. All right. That concludes this section. Thanks a lot. Bye.